My name is Dominique Fortier. I am a software development engineer lead in the mobility division. And today I'll be covering mobile gaming development on today's platform. Now, what does it take to write a game? It takes great video, awesome video, input, sound, networking, and again, performance, performance, and performance. Now, what will this session focus on? This session will focus on GAPI, the gaming API, and other technologies around it that will complement your game. This session will focus on GAPI today, and also what it means, the Windows Mobile 2003 second edition. You've probably heard by now of high DPI, of landscape. What does it mean to your game? If you are an experienced GAPI developer, you're saying, wait, I know most of that, but I really want to know what high DPI and landscape, how it will affect me. So just bear with me. I'll try to go as soon as possible into these details, and when I'm done with high DPI and landscape, I'll tell you, you're free to go now. I don't want you to be here and be bored, so I'll let you go as soon as it's possible. Now, video. What are your options? GDI is definitely an option. You can just use the regular Win32 APIs. I will not be discussing it in this talk, but just a tiny word. If you are going to use GDI, please create your original bitmaps in screen format. That's the way that you're going to extract the most performance out of it. If you're interested in writing managed games, I invite you to attend the CLI 346 session tomorrow, Game Development with the .NET Compact Framework. Now, I've said we have GDI, but that's not what we're going to talk about today. Now, am I going to talk about DirectX? No, because I'm focusing today on what is available for Windows Mobile 2003 and 2003 second edition. We don't have DirectX or hardware support yet. If you are interested in DirectX, D3D Mobile, hardware support, I encourage you to attend the CLI 353 session, which is later today at 5:45 in this very room. It's on the future of gaming on Windows Mobile. Now that we've ruled out DirectX, we've ruled out GDI, what is left? We're left with GAPI, the gaming API for Windows Mobile, and we're left with third-party solutions. Let's take a look at what was there from the very beginning and how it's shaping right now. So from the very beginning, on Windows Mobile 2000, on Pocket PC, we had something called GAPI, and we always had GDI as well. Now, Windows Mobile 2002 didn't see much new technologies. Windows Mobile 2003 introduced smartphone, and on smartphone you had GAPI as well. So now you have a common API between Pocket PC and smartphone. 2003 second edition introduced the concept of high DPI and landscape. Now GAPI will make use of that. For the future of Windows Mobile, we're going to the D3D mobile direction, and I will not be covering that in this talk. Now let's go to GAPI a bit. How does GAPI work? GAPI gives you access to the frame buffer in a standard way across all Windows Mobile devices. Now, how do you initialize GAPI? What are the steps needed to start using GAPI? You'll want to create your window. You'll want to open your display, query the different capabilities, open your input, and get the keys. Now, let's go into the details of every one of these steps. And along the way, I'll talk about high DPI landscape. So initialization, the main window. Why do you need a main window? It's the window that will be receiving the keys. It's also the window that will be hiding the taskbar, the SIP, the start icon, in order to give you access to the entire display, unhindered by the rest of Windows. Now, your window must be created before you can call gxOpenDisplay, which is the first function that you will call. Now, gx is display DRAM buffer. It's part of the initialization. What is that? Well, on some devices, we give you access to the real frame buffer. Some other devices, we give you access to a DRAM buffer. And typically, we'll use a DMA engine to copy the DRAM buffer into the frame buffer, the real one. Now, what does that mean for you? Typically, most games will implement a back buffering. Well, in the case where we are in the DRAM buffer, this is effectively your back buffer. You don't want to re-implement another back buffering, because at that point, you will be back buffer into DRAM buffer into frame buffer. So you have that API available that you can call to say, oh, if I'm already on a DRAM buffer, I might want to skip that intermediate buffering. Now, if you are in a DRAM buffer, there's a function that is very useful for you, gxSetViewport. If you're going to mix GDI components with direct frame buffer access, typical applications that use that would be video player, Windows Media Player type applications. Now, since when you call gxNdraw, it's going to copy the entire DRAM buffer over the frame buffer, it would effectively overwrite your GDI components. So you're going to use the gxSetViewport API to limit, to append the copy from the DRAM buffer to the frame buffer, allowing you to have GDI components outside of it that won't be overdrawn. Now, another very useful API is getDisplayProperties. This API will describe for you the display, the width, height, bit per pixel, this is what the BPP is, format of the display, is it 565, 555, 444, black and white display. It's also going to describe the pitch. Now the pitch is defined, some people will know that as stride as well. It's how many bytes do I need to move in order to increment by 1x and 1i the place where I need to be. So if you are in the corner at 0, 0, the x pitch will tell you move into the frame buffer by that many bytes and you'll be on the next pixel at 1, 0. The same is true for the y pitch. Now, I'm going to talk about high DPI now. Starting with Windows Mobile 2003 second edition, we have high DPI devices. Instead of being on Pocket PC, for example, instead of being 240 by 320 resolution, they're 640 by 480. Now, how does that affect your games? For legacy games, GAPI will emulate the game running at 240 by 320, so your existing games will still run. Now, on smartphone and on Pocket PC, the behavior is different. On Pocket PC, we'll see pixel doubling happening, such that the graphic will take the entire screen, but the pixel will be effectively 4 pixels for 1. On smartphone, it's going to be centered at the middle of the screen in real resolution with a black border all around. That's what's going to happen with the emulation for legacy games. Now, the mouse coordinate will also be emulated, so you really don't have to worry about it. If you want to bypass that emulation, we've provided you with a way to access the real frame buffer. So how do you do that? You don't call anymore gxBegInDraw or gxNdraw. Instead, you will call a next escape into the display driver to get the raw frame buffer. And you'll use the structure returned to you instead of the getDisplayProperties of GAPI. So you don't call BegInDraw and ndraw, so you don't jump into emulation. You don't call getDisplayProperties, you call an next escape instead to get the new structure that defines the display. Now your mouse coordinate, they can still be emulated, or they can be in real mouse coordinate of the screen if you want to. The way to do that is to rebuild your application for today and include the iRes aware resource in there. If you want more details on that, there was a session that we just passed, I think it was yesterday, about building high-resolution aware applications. It will be on the DVD, so you can reference it to have more details about it. Now let's look a bit at what the code for high DPI would look like. So here at the top, I define the different structures and pound define I need. And at the bottom, you can see how the X escape is done. So you get your DC, you call, give me the raw frame buffer. It's being returned to you in the RFBI structure, the raw frame buffer info, and then you release it. As you can see, the structure is a bit different from the GAPI structure. So if you want to move your application to be high DPI aware, you will need to use this one and the GAPI one at the same time, such that you can switch between high-resolution devices and low-resolution devices. Now, I suggest that you create your own structure that maps to both, and you just fill in both structures. Now, let's look at what it would look like, the different options, if you do bring your application up to speed or not. So let's take a quick look at it. Yeah, I know. I just need to set it up first. Now, this is an example of a landscape port image that if you don't do any work and you rely on the GAPI emulation, this is what it could look like. Let's try to focus in and see if we can see a bit more. Yeah, I think it's pretty obvious. So this is a straight pixel doubling without any algorithm. Now, if you don't update your application for IDPI, and you just say, okay, I'm going to go 240 by 320 on Pocket PC, I don't want to update, this is what it might look like. This is a straight pixel doubling without any algorithm. Now, it could look better depending on the OEM. So I'm going to put another device here that the pixel doubling algorithm being used is more weighted. So it's a way of the pixels around, and you can see it as kind of a blurry effect. But it's a lot better. But at that point, it's not your choice. It's how the OEM decided to implement the legacy layer. So it might look like the first one, or it might look like this one. Now, if you do decide to change it, this is what it would look like. This is I don't know if the Elmo represents truthfully what it is, but in this one, the edges are very sharp and very well defined. If you don't see really well, I invite you at the end of the presentation to come here and see the 3 different possibilities on real devices, not with the Elmo. So anyway, so just back a bit. Pixel doubling. No pixel doubling. Real resolution. High res, low res. I think it's pretty obvious that you'll want to convert your game to iRes aware. Now, what is the effect on performance of these emulation layer? Now, the emulation layer has to do the pixel doubling for you, and it can do a very straightforward algorithm, just the doubling, or it can weigh the pixels around and try to do a better job. Now, what that means is it's going to use a CPU to do that, and it's also going to implement a DRAM buffer because it won't let you write directly into the frame buffer. So performance will go down. So I suggest that you instead use the raw frame buffer and blit yourself. Now, landscape. What does that mean for with landscape devices? When you call GX Open Display, the system will be switched to portrait orientation automatically for you. When you call Close Display, it will switch back to its previous state. When you call Suspend, we'll switch back, resume, switch to portrait again. Now, I know that there's been a debate yesterday about that. This is great for legacy applications. Your legacy applications will still run. They won't know about landscape. Everything goes great. What if you have something that wants to stay in landscape? Well, I don't have a solution for you today. I've been made aware of the problem yesterday. I don't know the answer. I need to figure it out. So anyway, so if you are writing something that uses GAPI and you want to remain in landscape, I don't have an answer for you now. I know that you need an answer really fast. So so let's work today, James, and try to get an answer. I hopefully will have some kind of an answer tonight at the Meet the Expert session. If we don't, then just leave all of you your business card and we'll try to follow with you. So, for those that already know about GAPI, already are expert at creating games on Windows mobile devices, this is your cue. You can leave now. I have nothing new to teach you. For those of you who are new to this and want to have more information, let's keep on going. So, initialization, the inputs. Typically on a Pocket PC or smartphone system, the keys are being routed to do specific operations. Some keys will launch calendar. Now in a game, you want to have access to these keys. You want to be able to use the keys for your game. So this is what GX Open Input will do. It will route all the keys to your own application. You will receive them through WM key down, WM key up. You will use the GX get default keys to get the mapping between the conceptual A, B, C, start, up, down, right, and left keys to what is the VK that you will receive. Now, if you are on smartphone, there are two special cases that you will want to handle. VK back and VKN are going to be routed to your application. People expect when they press N that it's going to close the application. So you will need to close the application by posting yourself a WM close. Now when people hit back key on smartphone, they expect to go to the previous application. That's usually what the system does for them. So you will need to special handle the VK back and call the SH Navigate Back API. So here's an example on the initialization. First you find your window, because Pocket PC and smartphone are single instances, as you probably are all aware. So find your windows. If it's running, set yourself in the foreground. If it's not, create your window to be full screen. By using the get system metrics, you can take the entire screen. After that, open your display. Figure out if you are on a DRAM device. Maybe set your viewport if you need it. Get your display properties. Open your inputs, get your default keys. Now, what does your game look like? If you are an experienced desktop developer, typical usage would be peek message and draw as fast as you can. Well, you are on a small device, battery operated. You don't want to be drawing as fast as you can. If you do that, you'll probably run out of battery within what? Half an hour? 15 minutes? I don't know. But you'll be running out of battery very quickly. So avoid peeking your messages and just drawing as fast as you can. Be a lot more event-driven. Draw when you need. When you're in the background, stop drawing, stop animating. Even when you're in the foreground, if your game is animating on a steady state, the user is not actively using it, but you're animating stuff, after a minute, stop your animation until the user starts inputting keys again. That way you'll save battery life. If you're animating while the user is not using the device, you'll be draining the device of its power. So that's your main game loop. You're going to call gx_begin_draw. You're going to do your drawing, then end draw. It's very important that everything that you do is between the begin draw and end draw, because on DRAM buffer devices, it's on the end draw that we will copy the DRAM buffer into the frame buffer. Now, realize that if you are on a high DPI device, you will not want to do begin draw and end draw. You'll want to use only the frame buffer, the raw frame buffer that has been returned to you. What does gx_begin_draw give you? It gives you access to the frame buffer or a DRAM buffer. It initializes your DRAM from the VRAM. It returns to you a pointer that is either a pointer to the frame buffer, to a map frame buffer, or to a DRAM frame buffer. But in all these cases, the pointer is always located into the upper left corner of the screen in portrait. What that means is that it may not be a pointer to the beginning of the frame buffer. Let's say that the display for your device goes like that. It starts in the lower corner and goes like that. The pointer is going to be at the top left. But in order to go back to the very beginning, you might have to walk back from the pointer by as much as a stride. So it returns a pointer to the 0, 0 coordinate, not to the beginning of the frame buffer. After that, you'll want to either direct blit to the screen or draw into an off-screen buffer and then flip. Well, when I say flip, there's no real flip API. You'll be using a memcopy from your back buffer into your frame buffer. And then you call end draw, which removes you access from the frame buffer on some devices and kicks in, typically, the DMA engine so they start copying your DRAM to your VRAM. So here's an example. You'll want to do that on your WM Paint. You'll want to say, am I the foreground window? If I am, let's write what I have to write into it by calling begin draw, draw, and then end draw. If you're not the foreground window, please do not do that. If you're not the foreground window when you do that, you'll probably be overwriting whatever foreground window is there. Windows does not protect at all at that point. You have access to the frame buffer directly. So please draw only if you are the foreground window. Now, suspend and resume. What happens if your app gets deactivated? You will want to call gx_suspend. gx_suspend will suspend your display, refresh it to the previous state, to whatever Windows state it was, suspend your inputs, reroute the buttons to the normal behavior. Now, think battery life on suspend. Stop animating. Stop doing basically anything. Just stop until you're being activated again. Now, when you get activated again, call gx_resume, which will resume your display, hide the SIP, taskbar, start icon again, and reroute all the input to your application. Now, shutdown. What do you do on shutdown? Close your inputs, close your display, and quit. So now we've seen the main offering for Pocket PC and smartphones for Windows Mobile through GAPI. Some people have built third-party library on top of GAPI or not on top of GAPI. So I'll be mentioning them because they're very interesting if you want to write a game. There's GAPI Draw, which is a DDraw-like API that is on top of GAPI. FatHammer, 3D application for Pocket PC and smartphone. And there's a newcomer this year, Pocket HAL, which has been built by the person who used to write, what was the name of it? Pocket Frog. So Pocket Frog is no more, Pocket HAL is alive. It's GAPI-like, but he claims that it's more optimized, more performance, and support some hardware. So I invite you to look them up. I don't know much more than that about them. Now, D3D Mobile is coming. So just want to raise awareness to that. D3D Mobile is coming in the future version of Windows Mobile. So think about it too. Now, sound. What is there available for sound? Sound is Wave API based. We don't have direct music, direct whatever, direct sound. It's all Wave API based. There's two possibilities for sound. If you are on Pocket PC 2000 or 2002, there is no software mixing. Starting with Pocket PC Phone Edition 2002 and going forward with the original smartphone and Windows Mobile 2003 as a family, as a whole, we have software mixing enabled, PCM 8 to 48 kHz, volumes on individual streams, sine wave MIDI is supported, and configurable playback rate. Now, if you come from the desktop world, just a bit of a warning, we don't have sound buffers like in the desktop world, so you'll have to keep on monitoring your sound buffer. Another possibility for software mixing is Fmod. That's about all I know about them, though. Now, what about networking? You're writing a game. Now you're able now to write great graphics. You're able to output sounds. You have access to the input. Now, what about network-enabled games, online games? So WinSock API is the recommended way. It gives you access to TCP/IP, Bluetooth, infrared. Connection Manager is something that you will want to be aware of. Most of our devices nowadays are phone edition, either Pocket PC phone or smartphone. Connection Manager is the entity that deals with the concept of a phone and auto-connects you to networks and deals with what if a phone call comes in? How do we route this and resume the connection after? So for Connection Manager, the features are auto-dial. It deals with priority of connections. Will drop if you're lower priority your connection, enable another one, or deal with priority. It's a phone-friendly API, and I recommend that you go in and see the CLI 344 session, Building Network-Aware Applications for Sometimes Connected Mobile Devices. Now, James, correct me if this is not the right one, but I'm pretty sure it is the one that deals about Connection Manager. Okay. Now, performance. What can you expect? There's no floating point unit. So it's all going to be in integer arithmetic. Now, you can do floating point, but it will be emulated, so your performance are going to be bad. So I don't know if some of you remember the demo world from, how long ago was that? 10 years ago? Where everyone was doing optimized fixed point arithmetic. Well, you have to go back there if you want to extract good performance. Typically, we don't have a hardware blitter. Again, D3D Mobile is coming, and we'll have hardware support at that point. But until then, you cannot rely on hardware support. CPU power is roughly that of 5-year-old PC. So if you go back in your mind and 5 years old, what games were there available on PC, that's roughly the type of performance you can expect, minus the hardware support. So you can do pretty cool games on Pocket PCs and smartphones. I saw a quote yesterday from some vice president. I wish I remember the exact quote. But he was basically saying, this is amazing. We have the power of the desktop in small devices. And that's roughly true, 5-year-old desktop. Now, if you're going to do assembly, there is no inline assembly. But you do have an assembly compiler available to you. So if you want more information about performance, I want to refer you to these two URLs, which have been written for fixed point arithmetic and performance on the Xscale CPU. Now, what is available to you? You have the Windows Mobile Developer Portal, where you'll have technical support, tools, SDKs, emulators, developer community. If you want more, you'll get the Windows Mobile Solutions Partner Program, and then the Mobile to Market certification. Now, I've talked about a few other sessions during my speech. So these sessions were CLI 353, the future of gaming on Windows Mobile, which is at 544.5 in this room. And I've also talked about CLI 346, game development with the .NET Compact Framework. One resource that I wanted to point out that I haven't pointed out during my session is a website I discovered about a week ago called pocketpcdn.com. They have a very interesting discussion about GAPI. They give libraries that will let you load bitmaps and draw them over with GAPI. They're not IDPI aware. These samples are not IDPI aware yet, but it's still a very good starting point. If you're just coming up to speed, you say, I want to use that GAPI thing. How do I do that? pocketpcdn.com has a very good tutorial about GAPI. Now, thank you for being here. Don't forget to fill in your evaluation at the end of the session by going to mscorpevents.com/MDC, and there will be a 1 MPX 200 given away per scheduled slot, so don't forget to fill in your evaluation, and thank you for being here. Now, I'm pretty much ready for questions. So CLI 363 today at 2 o'clock. There's another connectivity session if you're interested in online gaming. Yes? What's the plan for inline assembly? Do you have any details on that, James? So basically what James just said is, in order to maintain the greatest compatibility, it's discouraged. Any other questions? I bet that it would stay. I bet that it would go to landscape, but I don't know. I've never tried. But I don't even have a... Do you know what's going to happen if they do that? I'm pretty sure there's no kind of like monitoring of the state. So open display switches you to portrait. Suspend and resume lets you go back to the old mode. Close display, go back to the old mode. His question is, what happens if you open display, it switch you to portrait, and then you switch it back again to landscape, you force it back to landscape? Or even, do we even have an API that they can call to switch it? So what happens if they do that? I don't know. You know what? Let me try that today. I'll come back to you tonight with an answer. I'd meet the experts. I'll just try it. We'll see what happens. Maybe that's your solution for what you want to do. Well, the problem is he's not writing a game. If he was writing a game and takes the entire screen, they're mixing GDI and GAPI, and that's where the problem comes in. There is? Yes, Windows Mobile 2003 second edition for high. There was no IDPI before second edition. His question is there, do you need a new GAPI to use the emulation layer? I don't know. I don't think so. I think, yeah, I think so, okay. So if some of you want to see the look on real devices, what the different emulation and non-emulation looks like, you're welcome to come forward here and just look at them. I have 3 different devices with 3 different ways that the graphic could look. So if you're interested, just come to the front and look at it. You can still do that. It won't cause you to. It won't cause you to call the emulation layer. So. Yes. Yes, exactly. So the emulation layer basically lies to your application and claims that it's a 240 by 320 device. And in the background, we'll do pixel doubling or black boxing of the application. Yes, it's on both devices. The raw buffer is implemented for both devices to let you access the full resolution. That's a bug, actually. The Toshiba, I have 2 different Toshiba devices there. One was the old way, and it tells you the real thing, and the new way, which they fixed, now lies to you and tells you it's 240 by 320. And when you call GAPI, the get display properties, it lies to you and tells you it's 240 by 320. If you want to get the actual frame buffer, you call into the display driver with an X escape, and it returns to you the raw buffer information without GAPI in the picture. You don't call open display, you don't call get display properties. You can get the real frame buffer, the real 640 by 480 frame buffer. But if you call get display properties through GAPI, okay. Yeah, so no. The answer is we didn't want to rev GAPI. Therefore, everything stays the same. If your application was built for GAPI, it's going to go through the emulation layer. It's going to lie to your application and claim that it's 240 by 320, and that's it. Now, if you want to rev your application, there's another API that you can call and say, give me the real thing, and that one will give you the real frame buffer. All of that for the real frame buffer. Exactly. So you don't call open display, you don't call get display properties, you call the X escape instead. This in the slides. So it's in the slides, and there's a white paper in the resource kit that you can reference. It's going to fail. On low-res devices, the display driver will say, what are you talking about? I don't know what that raw frame buffer thing is. So this is new, and if you're in your application, you don't know if you're going to be on a low-res or high-res. So you call it. If it fails, you call GAPI. If it succeeds and you have the bitmaps to go into 640 by 480 or whatever the resolution is, then you use it. If you don't have these bitmaps, just keep calling GAPI the old way, and the device will emulate you and just do pixel doubling, basically. Make a structure that will, or a class structure that will wrap these two things, such that your application can be written independent of it. Any other questions? Mm-hmm. The X escape? No. No, the X escape is a specific entry point into the display driver. If you're on a low-res device, the display driver doesn't know that and just says, oh no, I don't know what you're asking about. It would be really cool if in the future, even low-res devices would implement that, such that you can bypass GAPI and the whole DRAM to VRAM and access the real frame buffer directly. I agree with you, and I'm going to try to push that such that our OEMs support it even in low-res. But it's going to be ultimately up to the OEM at the end of the day to decide. Any other questions? Okay, thank you for being here. Yeah, sure. Let me bring them here or something. So, okay. So, if you look at this one here, okay, look at the edges around the rocks. Okay, so now you look. So this one is doing a straight pixel doubling, just taking the pixel and doubling it in every direction. So there's basically 4 pixels per pixel. This one here is doing a smarter pixel doubling. So there's a blur effect that you can see. But it's still through this is the emulation layer that the Toshiba implements with a more complex pixel doubling algorithm, basically. Yeah. And this one is the actual real high-res access. So you can see that the edges are very sharp. So if you look, yeah. So this one is implemented with more complex pixel doubling algorithm. So you can see the difference, right? This is the final. This is high res, and this is easy pixel doubling. Yeah. So really, like, I mean, it's not that much, but if you are playing a game, if you're looking like all the time very close, you'll see the difference. So there's a simple pixel doubling that just like copy. Another one is, I don't know the name of that technique, where you look around and you weigh, like, you look around more pixels and you do an average of them. And that creates that smooths the curve, but that creates kind of a blurred effect at the same time. So this device, that's how the OEM has decided to implement it. Now, I've faked the simple pixel doubling on it, but the OEM has implemented a more complex pixel doubling, which kind of blurs, but kind of make it look good at the same time. I actually don't know. I don't know how they've implemented it. Yes. what did you want to know about it? Yeah. Yes. Well, the emulator with the emulator you can fake any resolution, right? So yeah. So do you see the difference? Wait. Yes. Yeah, that just switches back between low and high if you do that on this device. Yeah, they can. Yes, yes, but you don't know that. It's up to the OEM. So, anybody else want to? This is like blurred versus low res with a complex algorithm and high res.
I actually just modified my latest game to work on this.
That doesn't lie. That tells you the truth. Yeah, that's a problem. It's not going to tell you the truth at the end of the day. It will lie. Yes. But wait. Toshiba will. This isn't shipped. Toshiba will not ship. I can guarantee you. With they are. Oh my God, that's so.
The retail version of Toshiba, you go to the store right now, Best Buy, buy one, it'll be for you.
Oh. So anyway, so it shouldn't be the case. It should lie to you and report 240 by 320, and that's. It shouldn't.
However, now
yes. But so yeah, that's crazy. It should never have been that way. It should have lied all the time. Well, it does now. Like one of these devices actually like does the right thing. I don't know. James, do you know if? Yep. When I saw that yesterday, not yesterday, a few days ago, when I started playing with it, I sent an email to my logo tester and says, "Now you have to logo gate that. There cannot be a device that gets out on the market like that." I didn't know about that device until a week ago, so. Yeah, something like that. They can't.
They showed it on that tour and
They can't. We hadn't shipped second edition yet. How could they do that? Oh.
There was no requirement back then.
I see. Yeah, that's how they got that. Because.
So the first edition Toshiba will not lie.
Yeah. Will lie. Yes. And they have to call. You have to call the escape to get the real information. What exactly? Yes. Well, exactly. The CPU use is directly related to power. It's a complete direct relationship. The more you use a CPU, the more you spend power. Because on these devices, anytime that you stop processing, the CPU goes to sleep. And the power modes are, there's many of them. The longer you can go to sleep, the lower the power mode it goes into. As much as you can. The less processing you do, the better the battery life. It's that simple. Because as soon as you stop, nothing to do in the system, let's bring down power mode. Oh, it's been a while, let's bring down to a lower power mode. Because the deeper the power mode you go, the longer it takes to restart. So the CPU is trying to be smart. It says, I'll just go to a low power mode. Oh, more time? Oh, let's go down, down, down. And at some point you reach a very low power mode. And when you start processing, it's going to take a longer time to restart, but you shouldn't see that much in a game, frankly. So completely, the less you use the CPU, the better you are. And it's that simple. Yeah, that thing that the thing that I've pointed out, pocketpcdn.com, that's what I've used to do that. It's actually bitmap. Like, it's a library where you can just plug in your bitmap and it draws it. It's pretty cool. It's just for entry person that just want to start using it. It's pretty quick. They're nice. Yeah, basically that's what it does. Yes, I know. But for somebody that just wants quick access, that's a pretty cool way to start. And after that, you refine your image format and your algorithm. Yeah. Yes. Oh, that's the thing. Windows Mobile 2003 Second Edition shouldn't switch res, shouldn't do that. It's a high res device. Yeah, exactly. Yeah. It's a high res device, and there's no switching res or anything like that. So I don't know if that makes sense or not, but.